Assalamualaikum and good day, folks. Welcome to chapter 2, matrices. In this topic, we'll learn how to represent numbers in rectangular form, how to describe their size, and what it means for two matrices to be equal. Matrices are everywhere in computer graphics, engineering system, and data science. So let's begin from the basic. A matrix is simply a rectangular arrangement of numbers in rows and columns. We usually name it with a capital letter such as A. The number inside are called entries or elements. If a matrix has m number of rows and n number of columns, we say it is an m times n matrix. That is what we call it. The row of a matrix is represented by the first figure in the element. And the number for the column will be at the second place in the element. So by looking at those figures, at the end, you can figure out what is actually the number of columns and rows for that particular matrix. So remember, when we said rows, it talks about the horizontal line. If we talk about column, it talks about its vertical line. The size or order of matrix describe how many rows and columns it has. For example, a 1 times 1 matrix has 1 row and 1 column. Basically, it's just 1 numbers. For 2 times 2 matrix, it has, of course, 2 rows and 2 columns, and so on. A square matrix has the same number of rows and columns. For example, both of these matrices are square because they are 2 times 2 and 3 times 3. In a square matrix, the main diagonal runs from the top left to the bottom right. These diagonal entries are 1, 1, A, 2, 2, until A and N. These diagonal entries are very important for many matrix operations later. Now, two matrices are equal if they have the same size and every corresponding entry is equal. That means the numbers in each position match exactly. Looking at this example, the value for W here should be -1, X should be -3, Y should be 0, and Z should be 5. and this will make them equal. Let's test another example. Matrix A is 2, 3. Matrix B is 1 times 2. And matrix C is also 2 times 3. A and B have different sizes, so they cannot be equal. But A and C can be equal if their corresponding entries are the same. For instance, A can be said to be equal to C only and only if X is equal to 4. If you're looking at this should be equal to 4. Then we can say that A and C is equal. Next, let's try this. Two matrices K and L are to be equal. So, what is the value of A that is to be substituted to make it true? So, basically, we want A to the power of 3 equal to negative 27 and A to the power of 2 equal to 9. Alright, try to refer to this one. So, let's try to look at the easiest one, which is squared, A squared. So A squared is equal to 9. So A is equal to square root of 9. If you solve it, we'll get it is either plus minus 2. 3. Plus minus 3. So you can simply substitute it inside here and figure out what makes which value plus 3 or minus 3 that makes it negative 27. So if you try to figure it out, you will see that the answer is negative 3. So for this question number 3, for the matrix to be equal, A need to be negative 3. Next, let's identify matrix sizes and diagonal entries in question 4. So first, let's look at order of matrix A and B. So this talks about the matrix sizes. So matrix A is 2 by 2 and matrix B is 3 by 3. The main diagonal for A is 1 and 2 pi, right? And for the main diagonal for B is 1, 5, 5. Next, let's determine the entries of A and B accordingly. So A12, where is A12? So we have A1 row 2 column. So we have A1 column 2. So this is A12. And then A22. So the second row with the second column. This is 22. A31. So of course you don't have the third row. So basically it is not possible for A. And A23. Of course we have 2 but we don't have 3. So it is not possible for A. Now let's look at matrix B. 1, 2. So column 1, row 2. So this is the first entries, 1 2, and then you have 2 2 2 and 2. So this is the entry for A22, and for A31 we have 3 and 1. So this is actually for 3 1 and 2 3, A23 2 and 3. So basically this is the entry or element for A23. So that's it for this part. You have just learned what a metric is and how to describe its size, the meaning of rows, columns and diagonal entries, and what makes when the two matrices are equal. So in the next lesson, we will learn the types of matrices in detail. Thank you.